So how do we show the relationships with our data? So it's easier to prove correlation than causation. And when you're looking at data, you might have a positive correlation where it seems like the scattered data all kind of goes, as one goes up, the other one also goes up too. As one variable increases, the other variable increases. A negative correlation is where as one increases here on the x-axis, the y-axis number actually goes down. So it still is lined to some kind of straight line. That would be a negative correlation. You can also have more of a parabolic type correlation. There's a lot of other curves that your data might follow, but as far as what we're looking at, these linear relationships are easier to see. You might, though, find that something has no correlation and there's not a pattern there. Now, don't disregard that data. That still says something, that there's no relationship here. It tells you something. You might have expected to find one, but don't let that bias your idea. It just means that actually people are all over the place in that situation. So it shows that there's no connection. So how do we figure out if a correlation is really causation? The answer is more experiments, studies, trials. The goal is to isolate and eliminate variables to see what actually is doing the causing. If you can isolate and get rid of different variables, then you can get closer to the answer of proving that it's causation. So here's kind of another example, causation versus correlation. So maybe you notice that there is a relationship between high ice cream sales and a rise in sunburns. Well, that is not one causing the other. So that is a correlation relationship. But the thing that's causing both of those is the sunny weather. The sunny weather is causing the high ice cream sales, and the sunny weather is causing the rise of sunburns. And so it's happening at the same time. So there's a relationship. Now, some people might say, well, actually, maybe people use ice cream on their sunburns. And that would be something you could look into further to see if that's true. But I'm guessing it's the sunny weather. So let's take a look at those variables here, the three main types of variables that you're going to encounter. The independent variable. That is the IV. It's the one I change on purpose. I decide ahead of time. I manipulate it. It's sometimes called the manipulated variable. And generally, you find that on the x-axis of a graph. The dependent variable is the data you collect in the study or the experiment. And it depends on the experiment, and it depends on the independent variable. It responds to the independent variable, and it may change. So independent variable starts with an I change it, I decide it. The dependent variable is the data you're taking. It depends on the others, and it may change. We don't know. We might find there's no correlation, remember? And then the last kind of variable is the constant variables or controlled variables. And notice there's plural on here because usually you have just one independent variable and then maybe one or a few dependent variables. But your constant variables, you want a ton of these. You want as many of other factors that could change to stay the same. You want them to be constant. You want them to be controlled. And this helps the experiments be fair. So all of these are variables. Think about that term, variables vary. They can be different. So some you're changing on purpose, so it's definitely going to vary. Some might change, you don't know, you're going to find out. And then these ones we hope will not vary, that there will be no change, that it's going to stay the same throughout the whole experiment to keep the experiment fair. But now remember, people are hard to keep the same. You can't study all of the same people that are the exact same age and height and weight and cultural background and education level and sleep level. All those things are really hard to keep constant. And so that's why we do large scale studies to see how people we can get better data if we do large scale studies.